We will now continue with our study of radical expressions by developing more skills on multiplying and dividing radical expressions. Now, let's start with a simple example. Multiply and simplify cube root 2 multiplied by cube root 4. If you remember, this is something we did in the previous class. Do you recall that? What is the principle we use in simplifying this? The product rule. Cube root A times cube root B is cube root of A times B. So combine this as one radical. That will be cube root 2 times cube root 4 is cube root of 2 times 4. That is cube root of 8. And what is cube root of 8? You must be now familiar with all the perfect powers. Cube root 8 equal to 2. Alright, another one. Multiply and simplify cube root 5ab squared times cube root 25 a to the 4 b to the power of 12. Again, we do the same thing here. A cube root multiplied by a cube root, you can combine the whole quantities inside one cube root. Combining this as one radical, we get cube root of 5ab squared times cube root of 25 a to the power of 4 b to the power of 12 is cube root of 5ab squared times 25 a to the 4 b to the 12. Alright, let's now multiply each of the like terms. 5 times 25 is 125. A times a to the 4. Look at that, you can multiply like quantities. A times a to the 4 is a to the 5. B squared times b to the power of 12 is b to the power of 14. There you are. So that is cube root of 125 a to the power of 5 b to the power of 14. Our next task is to simplify this. Alright, what do we do to simplify this? This is a cube root. That means you need to identify perfect cubes inside the radical sign. Let's start with 125. What is the highest perfect cube in 125? Let's see if anybody can recall that. What are the perfect cubes that we know? I have gone through with that several times. The first perfect cube is 2 cube, that is 8. The second is 3 cube, that is 27. The next is 4 cube. What is 4 cube? 4 times 4 times 4 is 64. And the next one is 5 cube. 5 times 5 times 5. That is 125. 125 is a perfect cube. So we will leave it. We can separate it out. A to the power of 5. Can you write that as the product of a perfect cube? If you remember, in the last lesson we did something like this. A power becomes a perfect cube when the power can be divided by 3. So, how will you write a to the power of 5 as the product of two factors so that one of them will be a perfect cube? Well, I know you can tell me that. A to the power of 5 can be written as a to the power of 3 times a to the power of 2. A to the power of 3 is a perfect cube. Alright, how about b to the power of 14? B to the power of 14. Again, a perfect power, a perfect cube will have a power that can be divided by 3. Now, what is the power that is closer to 14 that can be divided by 3? That would be 12. So b to the power of 14 will be written as b to the power of 12 times b to the power of 2. Alright, let's do that. We write the inside of the radical as the product of perfect cubes. That means 125 is 5 cube, which is a perfect cube. A to the power of 5 is written as a cube times a squared. And b to the power of 14 is written as b to the power of 12 times b squared. And I have used the red colors for the perfect cube. 5 cube, 8 cube, b to the power of 12. They are all perfect cube. We can now take them out inside a different radical like this. So I have now cube root of 5 cube, 8 cube, b to the power of 12. We have separated all the perfect cube terms in one radical. And the remaining, what are the remaining terms? A squared, b squared. That will stay in another radical. Alright? So that is cube root of 5 cube, 8 cube, b to the power of 12 times cube root of a squared, b squared. Can you help me simplify this? The cube root of the perfect cubes. What is cube root of 5 cube? Cube root 5 cube is 5. Cube root a cube is a. And cube root b to the power of 12, how do you find the cube root of a power? Divide the power by 3. So cube root of b to the power of 12 is b to the power of 12 divided by 3. That is b to the power of 4. So this will be 5ab to the power of 4 times cube root of a squared, b squared, and that is the answer there, the simplified form of that radical expression. Okay, I hope you followed how this is done. Let's go to the next one. Multiply and simplify. Now this is different this time. Square root times parenthesis square root 6 plus square root 2. What do we do here? Well, of course, we distribute the square root 2. This is just like, isn't it like the algebraic expression x times x plus p? What do we do? X times x is x squared, and x times positive p is positive xp. In the same way, we will distribute the square root 2 into the two terms inside the parenthesis. And how does that look? That will be square root 2 times square root 6. There you are. Square root 2 times square root 6 plus square root 2 times square root 2. Distribute square root 2. Multiply square root 2 with each of the terms inside the parenthesis. That gives you square root 2 times square root 6. That's the first term. Plus square root 2. Remember, the sign of that square root 2 is positive. So plus square root 2 times square root 2. And how do we simplify this? Square root 2 multiplied by square root 6. Combine inside the same radical. That will be square root of 2 times 6 plus square root 2 times square root 2 is square root of 2 times 2. Now, this is square root of 12 plus square root of 4. Well, you know this is the perfect square. You could have, from here, we could have said square root 2 times square root 2 is 2. We don't really need these details. But this is okay. Square root 2 times square root 6 is square root of 2 times 6, which is square root of 12. Can you simplify square root of 12? Square root of 12. Write 12 as the product of a perfect square. Alright? What is 12 equal to as a product of a perfect square? 12 is 4 times 3. So square root 12 is square root of 4 times 3 plus square root 4 is 2. Now, what's the next step? Split that into two pieces. Square root of 4 times 3 is square root 4 times square root 3 plus 2. And square root 4 is 2. So we got the answer. What's the answer? That would be 2 square root 3 plus 2. Okay. Again, a very important type of simplification. You must be very thorough with doing this kind of simplification. Another one. Multiply and simplify. Square root 3y times, in parentheses, square root 27y squared minus square root y. What do? Distribute the square root 3y. So multiply the square root 3y with each of the terms inside the parenthesis. And that is equal to square root 3y times square root 27y squared. Square root 3y times negative square root y makes that sign negative. Minus square root 3y times square root y. What is your next step in simplifying this? Use the product rule. Square root of a times square root of b is square root of a times b. So combine each term under one radical. That will be square root of 3y times 27y squared minus, here again combine the two under one radical. That will be square root of 3y times y. Alright, here now combine this. 3 times 27 is 81. And y times y squared is y cubed minus square root of 3y squared. Well, we now need to simplify the square root quantity. That means you need to write those quantities as products of perfect square. 81. 81 is a perfect square. Is that right? I think so. 81 is 9 times 9. Y cubed. Now, if you look our previous step, we had it as y squared times y. Well, this is y cubed. We need to write it as y squared times y. Why? Because y squared is a perfect square. And here, 3 does not contain a perfect square. Y squared is a perfect square. Alright, so what is our next step? Obtain perfect square product. That will be square root of 81 is a perfect square and y cubed is written as y squared times y. That means 81y squared is a perfect square. That's why I've colored it red. Or purple, I think, yeah. And this y is not a perfect square. Minus 3y squared. Y squared is a perfect square. What is our next step? Separate the perfect squares into separate radicals. So that will be square root of 81y squared times square root of y. Separate this into two radicals. Minus square root of y squared, the perfect square, minus times square root of 3. And now work out the perfect square radicals. Square root of 81y squared is 9y. Is that right? 9y times 9y is 81y squared. So this will be 9y square root of y minus square root y squared is y times square root of 3. We cannot do any more simplification on it, so we leave it as such. Okay, so all we did is first multiply and distribute, and then combine each term in a single radical, okay, and then write the terms inside the radical as product of perfect square and other terms, and then separate the perfect square terms into separate radicals and simplify. Okay, let's try another one. Multiply and simplify 7 minus square root 5 multiplied by 7 plus square root 5. Now, this is going to be the same as multiplying two binomials. Now, do you remember how to multiply two binomials? Let me see if I can show that to you one more time. Suppose I want to multiply x plus 4 times x plus 2. What's the method we used? Alright, watch this carefully if you have difficulty. First we take x, and now this is what we generally do. Take x and multiply it with each of the terms inside here, and then multiply 4 with each of the terms. Okay, I'm going to do that. Alright, that is, now what's my arrows that I'm doing? X times x is x squared, x times positive 2 is 2x, plus 4 times x is plus 4x, and plus 4 times positive 2 is 8. Alright, so one more time. X multiplied by x is x squared, x multiplied by 2 is plus 2x. We finished multiplying with x. Now we start multiplying with 4. 4 multiplied by x is plus 4x, and 4 multiplied by 2 is plus 8. And now we can simplify by combining like terms. Now, this is exactly what we will do here. Now, watch me. I'm going to take you through mentally. Alright, so watch that. Don't just wander away. What are the things we need to do? First, multiply 7 with each of the terms in the second quantity. That is, 7 multiplied by 7 plus 7 multiplied by square root 5. Okay, now minus square root 5 multiplied by 7 minus square root 5 multiplied by square root 5. Watch that negative sign there. Okay, let's write it down. Now, that will be equal to, let me take this away. This is the difference multiplied by the sum. But now, if you notice, this is actually the difference multiplied by the sum. If you multiply them out, you notice the middle terms will cancel. Is that right? If the middle terms cancel, what will be the terms left after that? Will be a squared minus b squared. Isn't it? Yes. So a minus b times a plus b isn't the same as this. 7 minus square root 5 times 7 plus square root 5. It's like a minus b times a plus b. Now, do you remember what is the product a minus b times a plus b. A minus b times a plus b is a squared minus b squared. I hope you remember. Well, let's multiply it out and make sure that it is actually that. Now, a times a is a squared. A times positive b is plus ab. Minus b times a is minus ab. And minus b times b is minus b squared. Is that right? Once again, a times a is a squared. A times b is plus ab. Minus b times a is minus ab. Minus b times b is minus b squared. And you notice in the middle, plus ab minus ab will cancel, leaving us the answer a squared minus b squared. So a minus b times a plus b is a squared minus b squared. Okay, can you tell me then what will this be? 7 minus square root 5 times 7 plus square root 5 will be the square of 7 minus the square of square root 5. So in this case, a equal to 7 and b equal to square root of 5. Therefore, 7 minus square root 5 times 7 plus square root 5 is the square of 7, that's the first term, a, minus the square of the second, square of square root 5. Tell me, what is the square of square root 5? Square root 5 times square root 5. What is square root 5 times square root 5? Is 5. So this will be 49 minus 5, and that is 44. Okay, let's do another one. A similar one. Square root 85 minus square root 82. Quantity multiplied by square root 85 plus square root 82. A minus b times a plus b. Your a is square root 85, b is square root 82. So, what will this be? This will be square root 85 squared minus square root 82 squared. What is square root 85 squared? Is square root 85 times square root 85, that will be 85. What is square root 82 squared? That will be 82. So that will be 85 minus 82, that is 3. That's very simple, is that right? But you must be very, very thorough with it. We are going to use it again later on in today's lesson. Another one. 1 plus square root of 5 times 6 plus square root of 5. Well, this is not a difference times a sum. This is the product of two binomial-like quantities. That means we need to follow the same method. 1 multiplied by 6 plus 1 multiplied by square root 5 plus square root 5 multiplied by 6 plus square root 5 multiplied by square root 5. I hope you can do that multiplication like this. First we expand this and look at the way it is expanded. First multiply this 1 with each of the terms inside the second parenthesis. 1 multiplied by 6, or we can do it like this. 1 times 6 plus square root 5 plus square root 5 times 6 plus square root 5. Alright? And that will be 1 multiplied by 6 plus 1 multiplied by square root 5. Alright? Plus, we finished multiplying by 1. Let's now multiply by square root 5. Square root 5 multiplied by 6 plus square root 5 multiplied by square root 5. Alright, let's multiply these. 1 times 6 is 6. 1 times square root 5 is square root 5. And square root 5 times 6 is 6 square root 5. And what is this? Square root 5 times square root 5 is a 5. Alright, so that will be 6 plus square root 5 plus 6 square root 5 plus 5. Can you simplify this further? We can add like terms. What are the like terms here? Well, of course we can add 6 and 5. And also, this is 1 square root 5 plus 6 square root 5. You can add those two. So that will be 11 plus 7 square root 5 is the answer. Okay, let's do another one. Multiply and simplify. 5 square root 6 plus 3, the quantity, multiplied by 4 square root 6 minus 2. Again, we take the 5 square root 6 and multiply the second quantity, and then multiply plus 3 with each of the quantities in the second parenthesis. And that will be 5 square root 6 times 4 square root 6 minus 2 plus 3 times 4 square root 6 minus 2. Alright, now let's multiply with 5 square root 6. That will be 5 square root 6 times 4 square root 6. Let's write that. 5 square root 6 times 4 square root 6. And now multiply 5 square root 6 times negative 2. That negative will give you a negative term, and that is 5 square root 6 times 2 with a negative sign. I wrote the negative first. So I finished multiplying this. Plus 3 times 4 square root 6. 3 times 4 square root 6. Plus 3 times negative 2 will be minus 3 times 2. Positive times negative becomes negative. Let's multiply. Now look at this one now. 5 times 4 can be multiplied. Square root 6 times square root 6 is going to be a 6. That will be 5 times 4 times square root 6 times square root 6 minus 5 times 2 is 10, and 10 times square root 6 is that term, plus 3 times 4 is 12 square root 6 minus 6. Alright, now let's multiply. 5 times 4 is 20. That will be 20 times square root 6 times square root 6 is a 6. So this will be 20 times 6 plus 10 square root 6. Look at the way I have combined them. 10 minus 10 square root 6 plus 12 square root 6. They are both like terms. You see, minus 10 square root 6 plus 12 square root 6 is a positive square root 6. Minus 6. Now that is 20 times 6 is 120 plus 2 square root 6 minus 6. There is one more thing to do. 120 minus 6 is 114. So this is 114 plus 2 square root 6 is the answer. A very important type of problems, you must practice this. Spend some time before you go any further. Try and do this on your own. You see, as I tell you every time, the method of learning algebra is by doing it. You don't learn by listening. You don't learn by reading. Algebra is understood and learned by doing. So you got to do it, then only you know where you go wrong and where you need help. Okay, so take a pencil and paper and do this multiplication on your own. Look at this. 5 square root 6 times 4 square root 6. There you are. Minus 5 square root 6 times 2, minus because of this, plus 3 times 4 square root 6, plus 3 times negative 2 is minus 3 times 2. And now, continue simplifying this and see whether you can do this on your own. Alright, let's go on and look at a different type of simplification. Simplify 5 divided by square root 2 plus 1. Now, what is it that we described earlier on in the last lesson? That an algebraic expression cannot have a radical number in the denominator, because that is irrational, isn't it? A radical number is irrational. Square root 11, square root 2, square root 7, square root 19, they're all irrational. Now, an irrational number is not allowed in the denominator. You need to eliminate it. Now previously, what did we do? Let me take you back. I know some of you need this revision. When you had, say, 5 over square root 2, we multiplied numerator and denominator by square root 2, and we produced the answer 5 square root 2 over 2, isn't it? This is what we did in the previous lesson. If I gave you a quantity like 5 over square root 2, to eliminate the radical sign in the denominator, we multiplied the denominator and the numerator by square root 2. Thereby, the denominator became square root 2 times square root 2, that is 2. Okay, we rationalized the denominator. Now, how do we rationalize this denominator? Can we multiply the same way by square root 2 on the numerator and denominator? Now remember, the denominator is a quantity. So if you multiply that by something, you must multiply that whole quantity. You cannot multiply anything on square root 2 alone. You can only multiply this whole quantity. Now, that means you must understand this as 5 over quantity square root 2 plus 1. You see, if I want to multiply, suppose I multiply denominator and numerator by square root 2. Will it help us? Well, let's try it. Suppose I multiply square root 2. Denominator and numerator. What is this now equal to? The numerator is 5 square root 2. The denominator, you need to multiply the square root 2 with each of these. So, you get square root 2 multiplied by square root 2 will be a 2. So, you will get square root 2 multiplied by square root 2 plus square root 2 multiplied by 1. You notice that here this becomes a 2, the radical goes away, but this now becomes a radical expression. That means multiplying the denominator and numerator by square root 2 will not eliminate the radical from the denominator. So what do we do here? Now this is where we practiced earlier, you know, a plus b times a minus b. Do you remember we just said a minus b times a plus b is a squared minus b squared. Alright, tell me, what is square root 2 plus 1 times square root 2 minus 1? Can you tell me what that is going to be? Square root 2 plus 1 times square root 2 minus 1. Well, this is the square of square root 2 minus the square of 1. So that will be the square of square root 2 minus the square of 1, and that will be 2 minus 1 equal to 1. You see what happened here? When I multiply the square root 2 plus 1 by square root 2 minus 1, I was able to remove the radical. The radical is removed. You see, square root 2 plus 1 times square root 2 minus 1 became 2 minus 1. The radical disappeared. So, what will we do to remove the radical sign from the denominator in such a case? I'm going to write that down for you. What will we do to remove the radical this time? To eliminate the radical in the denominator, we use the sum multiplied by the difference formula. That is, a plus b times a minus b is a squared minus b squared. Square root 2 plus 1 multiplied by square root 2 minus 1 is therefore square root 2 all squared minus 1 squared, and that is 2 minus 1. You see, now the radical is eliminated by doing what? Square root 2 plus 1 is multiplied by square root 2 minus 1. Now, when you multiply the denominator, you also have to multiply the numerator by the same quantity so that the value of the expression may not change. Now, watch this. The square root 2 minus 1, which we multiplied the square root 2 plus 1, is called the conjugate of square root 2 plus 1. So, square root 2 minus 1 is called the conjugate of square root 2 plus 1. Similarly, square root 2 plus 1 is the conjugate of square root 2 minus 1. Alright, in that case, tell me, what is the conjugate of 5 minus square root 2? What is the conjugate of 5 minus square root 2? It will be 5 plus square root 2. Is that right? What is the conjugate of square root 5 plus 3? The conjugate of square root 5 plus 3 will be square root 5 minus 3. I hope you are getting this. The conjugate of square root 2 minus 1 is square root 2 plus 1. The conjugate of square root 5 plus 3 is square root 5 minus 3. The conjugate of 5 minus square root 2 is 5 plus square root 2, and so on. Okay, let's do the simplification now. Simplify 5 over square root 2 plus 1. What do we do here? To simplify this, we multiply the denominator and numerator by the conjugate of the denominator. To eliminate the radical on the denominator, we multiply the numerator and the denominator by the conjugate of the denominator. What is the conjugate of square root 2 plus 1? It is square root 2 minus 1. So 5 over square root 2 plus 1 is now written as 5 times square root 2 minus 1 over square root 2 plus 1 times square root 2 minus 1. You see, square root 2 minus 1 is multiplied on the numerator and the denominator. It will not change the value of the expression. If you want, you can cancel them. Is that right? Yes. But do we want to cancel them? No, because we wrote it for a purpose. What is the purpose? The purpose is to rationalize the denominator, to remove the radical sign from the denominator. So what is my denominator now? Square root 2 plus 1 times square root 2 minus 1 is square root 2 all squared minus 1. And the numerator I can multiply. 5 times square root 2 minus 5 times 1, minus because of this minus. So the numerator is 5 square root 2 minus 5. The denominator is square root 2 all squared minus 1. And what is that equal to? What is square root 2 all squared? It is 2. So this now becomes 5 square root 2 minus 5 divided by 2 minus 1. And 2 minus 1 is 1. And the denominator 1 we don't worry about. So the answer is 5 square root 2 minus 5 is the simplified form of this. Okay, I hope you understood the meaning of a conjugate and how multiplying an expression like this, numerator and denominator by the conjugate, will eliminate the radical from the denominator. And also remember, a quantity like this needs to be inside parentheses. Very, very, very important. Another one. Simplify 2 divided by 5 minus square root 7. Look at the denominator. 5 minus square root 7. What is the conjugate of 5 minus square root 7? The conjugate is 5 plus square root 7. The conjugate of 5 minus square root 7 is 5 plus square root 7. What do? Multiply the numerator and denominator by 5 plus square root 7. Now remember to enclose the quantity 5 minus square root 7 in a parenthesis. Very important. So multiply the numerator and denominator by this quantity 5 plus square root of 7. So it now becomes, the numerator now is 2 times 5 plus square root 7, and the denominator is 5 minus square root 7 times 5 plus square root 7. Alright, can you tell me what will the denominator now become? Look at this, a minus b times a plus b is a squared minus b squared. So 5 minus square root 7 times 5 plus square root 7 is 5 squared minus square root 7 squared. We leave the numerator like that. There is no profit in multiplying it. So leave it like that. The denominator becomes square of 5 minus the square of square root 7. Okay, and what is that? The numerator remains the same. The denominator 5 squared is 25, and square root 7 squared, square root 7 times square root 7 is 7. So the denominator is now 25 minus 7. The radical sign is gone. The denominator is now rationalized. Now, again, the numerator remains the same. The denominator is now 25 minus 7 is 18. Now you notice one thing. 18 is 9 times 2. You can cancel a 2 on the numerator with 18, leaving a 9. You see? That's the advantage in not multiplying. There is no need to multiply in the first place, the numerator. So what are we left with? We have 5 plus square root 7 on the numerator and 9 on the denominator, and that is our answer. Okay, a very good type of problem. Let's try another one. Simplify 1 over square root 17 minus square root 8. What is the conjugate of square root 17 minus square root 8? The conjugate of this is square root 17 plus square root of 8. There you are. The conjugate of square root 17 minus square root 8. Look at the way I put that in a parenthesis. It's very important to enclose that quantity in a parenthesis. The conjugate of this is square root 17 plus square root 8. Alright, so what do we now do? Multiply the numerator and denominator by square root 17 plus 8. Remembering to keep the quantity here in parentheses. There you are. You watch me do that. So my numerator is 1 multiplied by square root 17 plus 8. My denominator is square root 17 minus square root 8 in parentheses times its conjugate square root 17 plus square root 8. The numerator will remain as it is, square root 17 plus square root 8, and the denominator is, watch again, a minus b times a plus b is a squared minus b squared is square root 17 squared minus square root 8 squared. Alright. You see, on the numerator, square root 17 cannot be simplified, but square root 8 can be simplified. You know that. So, look at the way I wrote my numerator. That is square root 17 plus square root of 8, I wrote as square root of 4 times 2. You know why I wrote that way? 4 is the biggest perfect square in 8. And the denominator, square root 17 squared is 17 minus square root 8 squared is 8. So the denominator now is 17 minus 8. Again, the numerator now is square root 17 plus. I have saved a step. This is now square root 4 times square root 2. Square root 4 is 2. So that will be 2 square root 2 all over 17 minus 8 is 9. And that is the simplified form of that rational expression. Okay, let's try. I think that's about it. Well, we have now come to the close of Unit 6. And I hope you have been doing your quizzes well. You have been doing all your homework. It is now time for test number 6. You can see we are fast approaching the end of the course. Test number 6. There is only one more unit left. This is the time you go back and do all the tests and quizzes one more time. If you noticed, I have been leaving the test and quizzes open for you, allowing you a second attempt. You know why I do that? To give you more practice. The second attempt is not used for grading. For grading, I will use only your first attempt score. The second attempt is for you to get more practice on solving questions of that type. Now remember, at the end of the course, you got to take a final and a state exit exam. In order to prepare you for that, you got to get sufficient experience in doing questions of that type. So it will be very useful to go back and start doing all the tests and quizzes one more time. And of course, look through the practice tests as well. I know if you make up your mind, you can do very well in this course. But you must be disciplined. You must be willing to sit down and work. Alright? Let me know if you have any problems. I will answer all your questions. We will start Unit 7 in my next lesson. And Unit 7 is on graphing. It's a very important and interesting unit, and I hope you will enjoy it. Alright, I will see you for Unit 7 later on.